In this video, we're going to review the dot product. So the dot product is an operation that combines two vectors and produces a scalar. And that scalar is a measure of the alignment of those two vectors. So for example, if we have two vectors, which we will call A and B, and just to remind you that A here is defined as AX in the I direction plus AY in the J direction, and B is defined as BX I plus BYJ. So we have the components, the X and Y components, and so we're doing this just in 2 dimensions, but this easily extends to 3 dimensions. So for these two vectors, we can define the dot product as A dot B is equal to AX times BX plus AY times BY. So we have the X component of A times the X component of B plus the Y component of A times the Y component of B. And this is the algebraic definition of the dot product. And there's a second way we can define this as well, equivalently, which is that A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between these two vectors. And this is the geometric definition. And here I'll just remind you that, or define that A here is the magnitude of the vector A, and here we have the magnitude of B. And just to recall here that we define the magnitude as the square root of the X component plus the square root of the square of the X component plus the square of the Y component. And theta is the angle between the two vectors. So what does this dot product tell us? If A dot B is greater than 0, then that tells us that the vectors generally point in the same direction. And conversely, if A dot B is less than 0, if it's negative, then the vectors generally point in opposite directions. Further, we can have the case that if A dot B is equal to 0, that means that the vectors are perpendicular. And if A dot B is exactly equal to 1, then that means that the vectors point in exactly the same direction. And finally, if a dot b is equal to -1, then the vectors point in opposite directions. One other very useful capability of the dot product is that we can also use that definition to find the angle between two vectors. And we can do this with the following formula. So we have a dot b, and the numerator and the denominator we have the product of the magnitudes of a and b. Now we'll do a couple of examples. So in our first example, we want to find the dot product between a, which is equal to 5i plus 4j, and I, our unit vector, pointing in the x direction. So to do this, we have a dotted with I, and so we can simply multiply the x components together and add those to the y components. So the x component of a is 5, the x component of I is 1, the y component of a is 4, and the y component of I is 0. And so we find that the dot product is simply 5. In a second example, we have two vectors. Again, we have the dot product I, and this time we have a vector which we're calling v1, and the angle between these two vectors is 180 degrees. And so we want to take the dot product between v1 and I. And so to do this, we're going to use the geometric definition, where we take the magnitude of v1 times the magnitude of I times cosine of the angle between the two, which is 180 degrees. And so here we have the magnitude of v1 is simply v1. The magnitude of I is 1, and cosine of 180 degrees is -1. And so we find that the dot product of v1 and I is simply -v1.